Good morning. Thank you for joining us for day 2 of the 2025 North Dakota Transportation Conference. Before we dive into the presentation, I'd like to remind everyone to please silence your phones and to hold all questions until the end of the presentation. There will be a Q&A session then. Now, without further delay, my pleasure to introduce our first speakers of the day, Deon and Steve. Today they will be discussing enhancing safety along busy corridors. Please join me in welcoming Steve and Steve to the stage.
Thanks, Jared. Welcome everyone today to our presentation here. Hope you had a great day 1 of the conference here. Looks like a lot of people are still recovering from their social nights last night, so definitely like to see you here. Thank you for coming to our presentation. We're really going to talk today about 2 different projects Steve and I have been involved in the last 4 years. One is on State Street here. And looking at the image here, we've got just going to talk about really how you enhance safety in these corridors. Obviously, we build in roads every day, and the main thing is just to make things are safe for pedestrians and motorists. And look at the image here. This is one of the intersections that we improved some operations on State Street. There's kind of items in white that you see are improvements that were made, and included turn lanes, aligning the crosswalks for pedestrians. Some of the things you don't see on here are like, even pavement markings and how you basically delineate the intersections for motorists to travel through these intersections. And also updating traffic signals and crash cushions. So there's a lot of things that we, different safety components that go to projects that, a lot of people don't see or do every day. So today we're going to talk about some of the improvements that we did, and then Steve will kind of dive into really some of the technical details of some of these items. As mentioned, my name is Deon Wawryzniak. I was a project manager for Houston. On this here. I've been with Houston for about 4 years. I've been in consulting since mid-90s, so I've been around a lot of DOT projects, working a lot of urban roads in the eastern part of the state, and especially in the Grand Forks area. And Steve will introduce himself a little bit later and his background. So really in North Dakota, we've got kind of 2 different type of projects. Either you got a rural project or you got urban projects. Really the rural projects we see here, everything has a safety criteria to it. Your rural projects you see here really look like kind of your typical rural highway throughout the state of North Dakota here, and typically you're looking for travel speeds, lane and shoulder widths, in-slope rates. Those are kind of the safety criteria you look for to improve your clear zone and guardrail type treatments. But when you get into urban settings, it kind of adds a whole new layer of complexity to some of the things that you got to go through and look at. That adds to the pedestrians, really the volume of traffic you see, and especially limited right of way. You get into some of the urban settings here. We've got buildings that right along the right of way. So how do you address that, and how do you make things safe for pedestrians, and also trying to make those pedestrian walkways safe along some of the urban corridors that we've seen some of the presentations yesterday. And so really it's there's kind of a mixed balance between trying to build an urban setting and make it safe for everyone involved. Probably the biggest things that we look at today, and that's why we're kind of focusing some of the heavy volume roadways that we had here today at State Street to 994, is the big difference is traffic volumes and how you handle those. An urban project maybe in Larimore, North Dakota looks significantly different than an urban project in Fargo, but they do share some of the similar issues when you're looking at pedestrian safety, some of those building issues like that. So, but how do we really safely construct a project like this? It comes down to traffic control phasing. As we talked yesterday, Director Henke's comments are, we're really trying to make this safe for everyone. At the end of the day, we all want to go home safe. It's either pedestrians, the motorists, it's the workers that are on the project site. So when we look at the biggest thing in safety is traffic control. Sometimes that gets neglected. You can put together a traffic control plan, and it can get turned upside down on you too. So those are really some of the things you look at between urban and rural, but we're going to really focus on the urban and some of the higher volume type projects. So State Street is really our first project we look at here. A little bit of the background of the project here. This segment was from Divide Avenue up to Calgary Avenue, so just on the kind of northeast corner of the Capitol campus. State Street itself was built in its current configuration with 3 northbound, 3 southbound lanes in 2002 from Divide Avenue up to I-94, and then it was extended up to Calgary in 2003. And so in that era, it was built with the 3 lanes we have each direction, but within less than 10 years in North Dakota DOT and the City of Bismarck, we're starting to see issues with traffic control and intersection operations through there. The corridor was having challenges, and a lot of it maybe has been due to the increase in volume of traffic with the oil field boom in the 2008 to 2014 era. So they saw a lot more traffic issues, led to some urban high crash location lists at a lot of the intersections. So they started studying the urban corridor throughout the divide to Calgary. There's multiple traffic studies done during this era, starting in 2011 with the North Dakota DOT having a traffic operations, evolved into Bismarck, Mandan, MPO studying, and various studies throughout up to 2020. And a lot of that focused really around the I-94 interchange and what we could do to improve that intersection itself. So those traffic studies kind of evolved into two different projects the DOT and the City of Bismarck kind of worked on. In 2018, they put blue light law enforcement lights at each of the traffic signals throughout the City of Bismarck. And in 2020, they updated the traffic signal coordination phasing sequencing to try and at least help some of the operations through this corridor until another project could come along. There was a safety improvements project that was put together in the early 2014s, which really was the kind of a catalyst to look at this, but it never got really to the final plan stage and bid to our project. So in 2020, North Dakota DOT had another traffic operations study, which really activated the project. With that, it brought forward the alternatives that were similar to 2014, but enhanced some of the characteristics of some of the alternatives that could be moved forward. And so some of the key components that we got involved with the design, really from the preliminary design, was looking at these design alternatives and making concepts to see how they fit the corridor. State Street obviously looks fairly wide, but when you get to the intersections, you're limited right away, and how you can make these concepts really fit each intersection. And then also utility coordination. You're trying to put traffic signals, you're trying to build out right in these busy intersections where everything's already got full infrastructure in there. So it became a challenge to utility coordination. And obviously traffic control, how you're going to phase work through this when you're trying to do CPR work and also do the traffic signals and some of the turn lane modifications that were proposed. So some existing conditions that we're posed with here is that the EDT along this corridor is 26,000 to 40,000 EDT. Really the bulk of that's focused in the I-94 area for the exits on both the north and south sides. Overall level of service had degraded to levels D and E for several intersections throughout the corridor. And so the purpose and need of the project was really established, which really defined what we need to do out here, and it was to really improve traffic operations at all the intersections due to increased demand, and then at the same time protect the pavement to reduce any future repairs along here. There had been a CPR earlier before that in the mid-2000s, and so it was time to really, now we're doing intersection improvements. We're going to have the roadway under construction. Now it's time to go in and really bring back the poor ride conditions that the road had been seeing. And at the time we did the study, we had 4 intersections that were on the urban high crash location list. So 2017 to 2019, there was reported 529 crashes through this corridor here. So that results about every 2 days there's a crash along State Street through this corridor. 55% of them are rear-end type crashes, but there's over 25% that are potential injury or more severe type accidents. That's about every 9 days there's a severe accident along this corridor. So these 4 intersections highlighted in yellow were when we started the project, and halfway through our environmental document, the last in Calgary got added to that list too. So there obviously was an issue. There was a lot of intersection operations being degraded, so the traffic operator study looked at different alternatives as to what we could be doing through here. Kind of came up with some alternatives that we developed concepts that we brought forward for management presentation of City of Bismarck commission meetings. We had business owner meetings and public input meetings, and obviously we've heard, it's hard to get public to come to these meetings and to get the voice or issues that they have along the corridor, and also from a business standpoint. So we went door to door and brought flyers and postcard reminders of what the meetings would be. We also had a social media post for that, but yet with all that input, it was hard to get them to actually come to these meetings and give us their input at the project development phase. So what you see here highlighted in orange is the whole safety improvements corridor here. It didn't really affect this State Street itself, it affected the side streets and how we integrated those into the State Street intersection operations. Some of the components of this project were the access modifications, which would help reduce the conflict points, increase turn lane capacities, and really the goal was to improve the overall intersection operations throughout the corridor here. Some of these alternatives that were presented as part of the traffic operations report and developed as concepts and moved forward into the environmental document for decisions was a partial median U-turn, which was called a partial MUT, adding dual left turn lanes, modifying right or left turn lanes, either extending them, adding them, or deleting a left turn lane to try and have the receiving lane for a dual left. three-quarter accesses at some of the intersections to really reduce those conflict points at some of the key locations that were pointed out during the traffic operations study, which then resulted in the right in, right out at some locations. So we balanced a lot of those trade-offs with our design, impacts to business and property owner access, and trying to figure out how you find a balance between consideration for motorists and consideration for the pedestrians and how that really affects everyone at the end of the day with all the end users on that. So with that, Steve's gonna kind of dive into some of these, what these alternatives really look like and how it advanced to the final product, what it was actually constructed. This project was constructed in 2023 and finished in 2024. And what you see today is kind of the final product.
All right, thanks, Deon. As Deon said earlier, my name is Steve Strack. I've been with Houston about 14 years now and work out of the Fargo office, and I kind of lead our traffic engineering, traffic operations sector. So we'll just start off a little bit about alternative intersections. As Deon said, the North Dakota DOT actually did the traffic ops report, and included in that report were 3 different types of alternative intersections. One was R-cuts, displaced left turns, and then the partial median U-turn. Just to get your attention, it does say partial median U-turn. There is a traditional conventional U-turn, median U-turn, and that just restricts the left turn movements on the minor street as well. So thought I'd just clarify that. But as you can see in this, sorry, my bad on that one. As you can see from this slide, here's just kind of the general operations of how a partial median U-turn works. And really it only affects your major road left turn movement. So if you want to make a left turn from your major road, you go through the intersection, take a U-turn at the loon. They can be signalized, unsignalized. It just all depends on volume. And you come back and you take a right turn into your side street. And really, you know, the median U-turns, the alternative intersections, those types of intersection alternatives, I mean, they're important. You know, as we move forward today, we have things like environmental concerns, limited right-of-way, limited budget, and really these alternatives help to, you know, kind of meet the need of how do we address capacity, how we address safety. So that is very important in today's world. So just talk a little bit about the pros and cons. So pros is they do eliminate 10 conflict points, and these are the conflict points that really result in some of your serious and fatal injuries. You know, that left turn, whether it be the angle crashes or the head-ons. Reduce delays in queues. So this is directly from the traffic ops report. I mean, it did show good improvement on both of those. Reduces complexity compared to additional MUT, just because you're only affecting the major road left turn, not the minor street left turn. And then when you're dealing with these urban corridors and, you know, when you have pedestrians present, you know, any type of coordination, anytime you can steal time to maybe help satisfy that, it's a plus. So, you know, any unused time you're going to have from your left turns can be used for other things, whether it be PEDs or some of your minor turns or movements. And as you can kind of see on the right, that is just a comparison between a traditional intersection and a partial median U-turn. So you can see that there is a good reduction in crashes, so it's a positive on the safety. So some of the cons, unfamiliar drivers. You know, anything new, you know, it takes time to educate the public. It takes time so they learn how to drive it. A big thing, Century High School, that would have been a partial median in there. So you can expect, you know, as you have school-age children, they're trying to have to learn something new, distractions. So there could be just some potential safety risks there. So something to be aware about. This would have been the first in the state of North Dakota. So I mean, there is that hurdle as well. And then of course with the public, you're going to get, well, I have to drive twice as far. I have to go through and come back. You know, and that's kind of misunderstanding that can be taught with education to show you, well, yes, you do, but it actually saves some time. And then there is some increased crash potential with right turns as you're coming back. Signalized U-turns, you know, with any coordination, you want to make sure that those are just properly timed. So yes, people aren't stopping multiple times because that will lead to frustration, that will lead to comments, and so it needs to be properly timed. Urban corridor constraints. You can see here there's 3 different options that are kind of laid out at Capitol here. The top one is what's needed to actually produce the required storage and turn lane lengths, and as you can see, you're kind of starting to back up into Spalding there. So that could be more confusion, more safety concerns. The middle one is keeping full access, and you can see everything is really condensed, and so therefore you're not be able to develop the full cross section that you need. And the bottom one is kind of a quasi mix between it, right in, right out. You're pushing your queues or your storage a little bit further out. So there is that, balance between operations in the corridor. And then things like century code, how do you treat left turns on red? So like I said, I just wanted to touch a little bit upon that. It is important that we talk about these things because as times move forward, it's the education, it's the introduction to these concepts. I like it too, like a roundabout. 10 years ago, you said roundabout, everybody was scared, wanted to run away, and now it's commonplace. They're familiar with it, and maybe the partial median U-turn or other alternative intersections will have that place as well. So we'll go and talk about just the improvements that we actually implemented on the corridor. So safety improvements for light yellows, red signal. Says here additional signal faces. This is just kind of putting a signal right over the lane to kind of help that visibility. That way traffic doesn't have to look left and right. It just helps, see that red or the yellow and stop. Improve signal timings. They did go through and do the signal times in the corridor. So signal timing is an FHWA proven countermeasure, and that's a 14% crash reduction. Law enforcement red lights, they've been used in Bismarck for quite a while now. They're over the place. This alone in itself, it all comes down to enforcement, how well they want to be enforced, but if they wanted to curb that, it certainly does help police to do that. Reflectorized backplates, as you can see there, it just brings so much more attention at night. It kind of grabs it and helps you see that. So once again, those are FHWA proven. Safety improvements, access and turn lanes. Won't spend too much time, but I'm sure if you've ever been at a negative offset left turn lane, as you approach it, you kind of feel the risk tolerance kind of heightened. You look around, you're like, all right, do I go, do I not go? And so you kind of have that risky behavior. And so we did use protected left turn signal phasing for that. Extended turn lanes to improve capacity, that also can reduce rear end crashes. Access management, so the image on the right-hand, or lower right-hand side there, that's interchange. I used to live down that street, and so I'm very familiar with this at AM and PM peak times, and you can see who's wanted to go left, straight, it's impossible. So then you start to get risky, and that's where accidents happen. And there was actually quite a few complaints about the local police department saying, this is risky, we should do something about this. And just quickly, I'll touch we did install some fiber and then some ATMS, some advanced traffic management systems. Maybe not a true safety countermeasure in the sense, but it does give the city a plethora of data to use in the future for like signal timings. They're able to remotely change signal times on the fly, like for snow events. So, like I said, not necessarily a traditional, but it still does improve safety. All right, and then I'll transfer back to Deon.
Thanks, Steve. Before we get off State Street, the North Dakota DOT did submit State Street and they did receive a regional award for the Safety Medium Project category from the 2024 America's Transportation Awards Competition. So congratulations to DOT for submitting that and receiving an award for that. Also, State Street's been submitted for the 2025 ACEC North Dakota Engineering Excellence Awards Transportation Division. So in May at their banquet, the selections of the recipients of those awards will be out there. So hopefully State Street has another award for that. So now it's time to really merge into another project that's really kind of unique. It's not something you'll probably see in North Dakota, but it's involved in a project that we do have involved with the NDDOT and with the North Dakota DOT with the Red River Bridge crossing in I-94 in Fargo-Moorhead. So really this project started out as the North Dakota DOT completed the CADX for this project. It's a structures rehab project on the twin structures that cross the Red River. They are actually two bridges that are there. They're built originally in 1958. They were widened to the 3 lanes that they have today in the 1992, 1993 construction seasons. And so really our work became mostly a typical rehab project on the bridge. Guardrail designs for each state. MnDOT has a slight variance in what they do in their maintenance forces, so we had 2 different designs for the guardrail. They look very similar, but they have a little different plans that we had to put together for each one of those. Approach slab and the roadway panels on each side were replaced to add expansion and to provide a little bit of movement for that roadway through there so that we could remove the bumps that are entering and leaving both the westbound and eastbound directions on each structure. And as this is really the first deck overlay on the bridge, you can see there's a lot of repairs, spalls have been done throughout the years with MnDOT, North Dakota DOT forces. And so now is a chance to really go through, update, put a new deck on it before it's programmed for a construction or full replacement here in the not in the near future, but it's on its plan. But this will get by some time to get through there, and also we updated the deck icing spray replacements. This bridge has one of the 2 or 3 in North Dakota that have the de-icing system for that. So we went through and are updating all the de-icing pucks that are going to be in the roadway once they replace do the deck overlay on this one here. But really it came down to how we're going to construct this. We've got 35,000 ADT on the structures, the 7.5% trucks. Obviously there's a lot of traffic going through the Fargo-Moorhead area. And how are we really going to do this safely? So it came down to a lot of conversations between North Dakota DOT traffic and MnDOT traffic and working with the counterparts at D4 as to how to build the bridge. Originally started looking at 3 different phases, and then once we got into that, it was difficult to really keep 2 adjacent lanes of traffic. That was kind of the key, is to keep a minimum 2 lanes of traffic adjacent during all daylight hours. So we went back and looked how we can really do that, how the bridge geometrics are, and we come up with to really build this project in 2 phases on each half and allow the contractor to work on both structures at the same time to minimize really downtime, because they could work on one side and switch forces so we can keep working throughout the summer. And so really what's our presentation here is really dive into is what we had to do really on the Minnesota side. I'm not sure if it's hard to see in the bottom image here, but the bridge has 3 lanes, northbound or eastbound, westbound on each structure. So once you enter and exit into North Dakota, there's really no issues with transitioning in and out of the work zones. Eastbound directions into Minnesota, we have two through lanes that are continued eastbound. We also have the exit lane that goes up to US 75 or A Street. So there's an option for people to get off there. There's gonna be a little transition, but it was a little easier to maintain the 2 lanes of traffic for eastbound. But MnDOT really had some concerns on how we are going to approach the westbound traffic entering the structure in the work zones when we have 2 westbound lanes, and then they really merge in with that 3rd lane that comes off the US 75, the diversion diamond there. So really became an exercise in traffic control, and that was really the main part of this project, as to how are we going to address the merging traffic from both the northbound, southbound directions on US 75, and then that's how they merge onto westbound 94. And we gave the contractor working the DOT, they have 80 calendar days to complete this work safely. So we definitely need to find a way to get traffic in and out of the corridor and still be able to construct this and give the contractor some room to work and complete their work. So night work is involved on this project, but that's where we can minimize the lanes down to a single lane in each direction, but that's gonna be very limited actions and operations going on. So with that, Steve's gonna really talk about how we got into intelligent work zone discussions with MnDOT.
All right, make sure we're on the right slide here. All right, so intelligent work zones. So really with this project, I mean, it came down to 3 main drivers. So as you can see on the lower left-hand side there, so the ADT of the A Street westbound entrance ramp is about 15,000 cars. Comparatively to the interstate itself, I think it's right about that 28,000 mark. So I mean, it's a good percent of the traffic on that facility. And then as you can see from the lower right-hand side, so that is going to be the cross-section during when the bridge is under construction. So you only have two 12-foot lanes, severely pinched in by Jersey barrier or bridge barrier on both sides. So you can expect, you're going to have those cautious drivers going probably pretty slow through there. So you're going to have major speed reductions, capacity reductions above and beyond, just removing that added turn lane or added entrance ramp lane. And then you have the history, construction history. So the upper right-hand side there, that is from a crash from a 2022 construction on 94, and it did result in 3 fatalities. So, I mean, as traffic engineers, as engineers in general, that's what we want to avoid. We want to try to do whatever we can so that accident doesn't happen. We don't have to hear about that in the news. We don't have to have that happen to people. So that's really where this project kind of starts. So what are the solutions? So earlier on, we did meet with MnDOT, DOT staff, the city of Moorhead, and HEI. We had a meeting, and we kind of explored what are some potential options. What do we think would fit for this corridor based on the conditions? And what we kind of came up with is temporary ramp metering, end of queue, downstream speed notification, and congestion advisory. Those were the ones we wanted to target and to look into and analyze a little further before we just went and put them out. And kind of a really nice tool that we use throughout this is MnDOT's IWZ toolbox and also their checklist. They're just a good source of information for all these type of temporary ITS measures, anything related to construction and work zones. So we'll go into what is temporary ramp metering. I will preface this with saying, like, ramp metering itself, it can be very complex. There's a lot of things to think about. So this part of the presentation is only meant to serve as kind of a high-level overview and just kind of what we did the project. So temporary ramp metering, it's a strategy. What does it do? So it's aimed at addressing non-reoccurring congestion, and a good example of that is construction. It can do reoccurring, like that's your AM and PM peak hours. But for this, it's really trying to get that construction congestion. So how does it do that? It regulates flows entering the freeway. By using a traffic signal, it'll limit how much traffic can get on there. And it's really meant to break up platoons as well. I mean, you can imagine if you have 4 or 5 cars that are trying to jam their way on the interstate, then what happens? The interstate has to stop, they slow down, and then everybody starts slowing down. You get this cumulative shock wave that goes through the system on the interstate. So by kind of releasing them maybe 1 or 2 at a time, it really helps that smoothing of the merging operations. So a very important thing is objectives. What are your objectives? I mean, obviously, one, you do want to improve your freeway mobility. That's probably the top one. But there also is a balance between freeway and arterial. There are certain conditions where at times you can get that perfect balance, and there's times when you can't. Maybe, like in this case, the traffic is just too high, where you're never going to get the perfect balance, where the interstate operations are great and you have no, backup on your arterial. They're all different. So it's very important to sit down with your stakeholders, sit down with your DOTs and your cities, and be like, all right, what are we trying to do here? What are our objectives? And then to analyze that system as well, so that you know exactly what's going to happen when you get out in the field. I mean, you don't want to just put a ramp metering system without kind of looking at it. Be like, all right, well, this extends the queues for 2 miles here, maybe a mile on the arterial, or there's things that need to be thought about and at least talked about when you're talking to your stakeholders about this. And I will just note that is very similar to a permanent, just usually typically less complex than a permanent ramp metering. And so what we did for our project, there's either coordinated, locals, think of it more to kind of like an isolated interchange, just one at a time. Coordinated, think of it like a major a freeway where you have multiple ramps that you want to kind of do ramp metering. So for this, we just have the 1A street. So we used a local approach. And usually that has really less complex algorithms, and the math behind it, it's more simplistic in nature. Pre-timed, fixed, or responsive. So it goes down to what is your congestion, is it reoccurring AM, PM, peak hours, or is it does it fluctuate through the day? So we kind of figure with construction, it's more in that responsive nature where at certain times of the day, it's going to be operating a little differently. So it has more time to adapt as it kind of takes in the mainline data collection. There's a few different kind of timing plans that the controller selects. And then hour operations. Obviously, you don't want to use it when you need it, because if you use it all the time and they don't have to stop, they'll just, non-compliance, they'll just be, all right, I'm not doing this, didn't blow through it. So it's really kind of, establishing the hour operations, so that way there is good compliance. All right, so this is just kind of a general overview of ramp metering. Like I said, kind of really simplistic. But your major things are your mainline detection. That's going to collect your flows, your speeds, your occupancies, which is very important for determining your ramp metering rates. Then you have your ramp demand. That essentially just notifies the controller, hey, there's someone here that needs to be served. You do have your passage. Those are optional. Sometimes they're used to kind of just change the green to the yellow. Ramp queue detectors. So that's kind of going back to the balance. If you can in a system, you don't want that traffic to back up onto the arterial and cause issues there. So that just kind of helps the controller know, hey, you need to meter him a little faster, flush this ramp. And then all our operations are controlled by the traffic signal themselves. So usually there's 2. I mean, it can vary whether they're post-mounted or overhead. They can have red, yellow, green lights, so they can just have yellow and green, or yellow and red, or yeah. green and red. So there's some differences there. And then your ramp meter controller. Think of it as the same as like a traffic signal controller. It's your brains. You know, it's going to compute your logic, carry out how you want that system to operate. So really, not a whole lot different there, just a few less pieces of equipment. All right, so I go back to, I said, you know, the analysis is important. You want to understand how this system operates. And so we did use microsimulation modeling. We used transmodeler for this. You know, the highway capacity manual would be nice, but there are some limitations to that, and temporary ramp metering is one of them. So to address that, we did use microsimulation. Anything with microsimulation has to be calibrated and validated. So we did do that process thoroughly. We were able to use, thankfully, the FM interstate operations study that was completed for some of that calibration and validation data. So that was very beneficial. But so just going in, I think the most important thing is that heat map on the left. So on the top one, you have just the construction-based model, nothing done. And the bottom one, you have the temporary ramp metering. And this is during the AM peak hour. So the one thing very important to notice on the top for the construction is that that solid red color. So that is going to be your queue. So as you can see, you know, downstream, the queue starts to build, and the red, you know, it backs up all the way to Main Street. So that's about 2 miles. 2 miles of traffic at 5 miles an hour. That's going to persist for at least half an hour, and then it starts to dissipate. But as you see in the bottom, when you start to implement that temporary ramp metering, that queue gets brought forward way further. The speeds start to increase, and your operations are a lot better with that. I mean, I will say there's a caveat that you still, I mean, anytime you're putting more delay on the ramp or the arterial street, you do have some negative impacts there, but in our case, the objective was to maximize the interstate operations as much as possible. And I think with this temporary ramp metering system, we did that, and it will accomplish its goal. Temporary ramp metering implementation. So being this is in MnDOT, we did use MnDOT standards. It will actually be controlled out of the Twin Cities in their regional traffic management center, the RTMC. They'll operate it. We did install fiber so that they can remotely operate it, use their algorithm, and really the system, especially the detection, was designed for use of that. So that's just a thing to be aware of as well. And then we'll just touch base on some of the other ITS measures. That would be the end of queue, downstream speed, and congestion advisory. Some of you may be aware there was a end of queue system that was deployed by the DOT back in, I think it was 2019 through 2020 on the Bismarck Mandan corridor. So this is very similar, just kind of builds upon that and adds a few more features. So these are just kind of some cut shots from that Minnesota DOT IWZ toolbox. Once again, kind of handy where it gives you a lot of tips and tricks. But really, it's how do we take these 3 different systems, meld them into one, and get them all to work, but doing it at a reasonable cost and efficiency as well. So really, it comes down to 3 things. It's the efficient use of sensors. You know, how do we use these sensors at the very beginning of the project to control 3 systems? So as you can see here, I mean, this is just the standard end of queue. You know, as traffic backs up in detectors, it just turns on the various different signs, whether it be the slow traffic ahead, repair stop. So nothing too crazy there. But this is really kind of getting that back half of that, you know, things like controlling speed, trying to stop those rear end accidents, trying to stop that picture of that fatality you saw there. You know, and then the congestion advisory. So once again, these use the same sensors downstream, but they are just triggered by the data from those sensors. Usually it's all speed based. If you meet that threshold, it'll turn this, like, say for example, the congestion advisory. I mean, that doesn't turn on until there's speeds below 20 miles an hour. And then they turn it on to try to help alleviate some of that traffic and maybe get some of that traffic to divert to some other interchanges. And then, yeah, like I said, the major thing about downstream speed is obviously it needs to be upstream of the queue because it does nobody any good if it's downstream. So just a couple things to think about there. And then I will pass it back to Deon for closing.
Thanks, Steve. Obviously, we're not magicians. There's no magic to a lot of this stuff. There is a lot of a lot of things yesterday at the Magician that did that we're, still trying to figure out how he did a lot of those card tricks. But what we did here, like Steve said, there's a lot of analytics, there's a lot of modeling that goes through this. So in closing, really, a couple of things we want to take home with this is that safety is really starts with the stakeholders of your projects, working with your clients, it's either whether it's the cities or it's the DOTs. Up front, really figuring out what you're going to incorporate in these projects permanently, type things that we talk about, traffic signals, your pedestrians, all that type of things that really are going to be incorporated permanently in your work. But most importantly, too, is consider temporary traffic control and how you're really going to phase these projects to be able to build them, especially in urban settings where you've got a lot of traffic day and night. Keeping it safe for all the public to get through there, for the pedestrians, and also there's a lot of things going on outside that when you're trying to put plans together is to keep mindful of safety. And also, just the intelligent work zones is a thing that's coming out there. I know MnDOT has a lot of that stuff, and you see a lot of temporary metering in the metro area when you go down there. It's similar concepts, but also you can start seeing some of these advanced warnings and some of the queue detection just to try and avoid those congestions up front. So with that, obviously we talk about the main objective is just to make it safe for the public to move safely each day, in and out, get home at the end of the day. So with that, we've reached the end of our road of our presentation. So we're here for questions. Our contact information is up there if you wish. And thank you for attending today and listening to us.
Sure.
On State Street, why didn't you look at, on State Street, why did you not review a roundabout as an option for reducing conflict points and complexity in the intersections rather than just continue with the signals?
Sure. Yeah, I mean, I think I can answer it. And like I said, the traffic ops report was done by the North Dakota DOT. So kind of every ideas were flushed out before we got them. But I think the one thing you will find is when you're talking about roundabouts, really for State Street, that would have to be a 3-lane roundabout. And at this point, I'm not sure that too many 3-lane roundabouts are operating in the U.S. So once again, there could be some confusion and some driver education. So I can't say that was for sure why it was ruled out, but that's where my mind goes when I start to think about 3-lane roundabouts. So.
On the rear end crashes on State Street, was that primarily distracted driving, or was there a look into that and the measures to correct that?
Again, a lot of that information came off the crash summary. A lot of you look at some of the police reports, it's just regular accidents. This is some of the phasing. It signals the way it looks. There's a lot of traffic through there, and a lot of it's up in the Century Avenue. There's a lot of crashes in that neighborhood there. We've got a lot of younger drivers possibly too, but it's just, I don't know if it's distracted driving, but there's a lot. It's throughout the whole corridor, and that's kind of a predominant crash you have out there. So it could be down to signal phasing, just inattentive driving. And not a lot was weather related either. It was a lot of just dry condition type crashes too. So there's just a lot of different factors into those crashes, and when you get out of summaries.
For the I-94 interchange, the ramp metering, obviously the loop detectors were necessary. Were those in place, or do those need to be installed before the project begins?
Yeah, no, there wasn't any detection in place. So MnDOT kind of wanted this to be a temporary system, but it was kind of almost built a little bit permanently too, where, I mean, we actually did use, instead of, type of video detection or radar, we actually did use physical loops. So, like, that's what they wanted. So they'll be cut in the pavement, and we actually did our ramp metering signals with foundations. So we'll cut some squares out in the shoulders and put those in. So everything is, like I said, it's kind of more of a traditional loop-based system.
So same project, question about the ramp metering. With there being such a high ADT on that bridge, I believe it's close to 100,000 at the Red River Bridge. Would you need to do ramp metering at the previous ones, or did you just look at 8th Street? Like on the North Dakota side, you might need to do like University 25th and back, and on the Minnesota side, I know the specific fatality, it was much further back, and part of the reason was you have 2nd and 34th coming in, and you don't really have offs, ways people can get off before you get up to 8th very well.
Yeah, and so that's really what this kind of started from these discussions with MnDOT. So I would say it was limited to that because that's where it started. We didn't expand it out the whole system because I guess that was more or less, if you want to call it, maybe a little outside of the scope or the purview, or I mean, and really this is kind of, I mean, partially as well, it's kind of treated as a test section, right? I mean, it's never been done in North Dakota that I'm aware of. I mean, once again, the drivers may not be very familiar in Fargo, Moorhead. Sure, and maybe in the cities, they understand wrap metering perfectly, but up there, I mean, it's a different operation, so I mean, so in that regard, maybe it is best to test one than the others. But like I said, we did when we did model the system, we did it all the way out to University, and also I think like 4 miles back. So we did encompass all those interchanges, and it does extend that far back, that queue, and that's where you're saying that's kind of where it happened. It wasn't right at A Street. It was further back as Strack builds. But so long story short, it was just A Street for this project.
Question over here. I might have missed this, so I apologize if I did. Was there like direct business engagement for State Street in Bismarck?
Yes, we had business owner meetings. We basically had 2 different meetings, one for kind of south end, south of 94, and one for north end. So we went to each business, brought a flyer to them, a kind of reminder, and they also sent to each parcel owner too. So either the business owner, if they're a leasee, or the actual property owner got notifications. And so we held them up on the north end, up on the hotel on the hill. But we had limited involvement, participation from some of the business, but each were notified and brought forward. But thank you.